Okay, so I'm creating exam 1 today. It will be on Canvas. It will have no time limit. You have 1 week to work on it. It will say unlimited attempts, but that means that when you write a response, because it will have a written response section, you can maybe change your mind and come back the next day and write a different response. And if maybe like that was a mistake, don't worry about it. If you have the correct answer somewhere, I will use that as your score, or use that to give you a score. So I'll keep it like highest score. You don't have to show your work, but please make sure that you understand what's going on. And if you have questions, just ask me questions. I guess talk to your classmates, but try not to get help from a tutor. Also, I'm trying not to trick you, so if you forget to simplify your answer, that's okay. Just as long as you have the correct answer, that's what I'm looking for. So I think that's everything I need to say about the settings on the test.
Professor, I have a question for homework number 2.
Oh, yes, thank you.
Yeah, so for that one, I think it was question number 6. I tried like every single one of those answers and it still like marked it wrong.
Okay. Yeah, someone in the last class said something was wrong with this homework too. So I put a Post-it note to myself. I'm gonna go through and manually grade it. So
Okay.
if there's like no right answer, I'll just give the points. Or if I see that you did get the right answer and it marked it wrong, I'll give you the points.
Okay, thank you. Oh yeah, that too. It did have 2 40s for that as well.
Yeah, I saw. It was just my mistake.
Okay.
I'll fix it. Yeah, thank you. And let me see. It's homework 2. Number 4, I think.
It was number 6.
Number 6. Okay, thank you. That helps. Yeah, let me know if any mistakes happen. I'll fix them. I think that's it. So I'm going to put down all the topics that will possibly be on the test, and then we'll go through and do examples. We'll come back Thursday to finish examples and take any questions that you have on the test. I could always make a similar but different problem and just help explain. Okay. So we talked about sets, and let me get my packet. We did frequency and relative frequency. And I'll be doing problems that will be similar to exam problems and also similar to your homework. The difference is that you don't have multiple choice answers, you have an essay response answer. You don't have to write any essay. This one won't have any essay questions, I don't think. You can just put a number as your answer and that's okay. Or, you can just put down your answer and that's okay. All right, we did interval notation. This is probably where we're going to get to today. And then next time we're covering bar graphs, and histograms. And then I will ask about just the mean and the median. I'm not going to talk about the mode this semester. We did do dot plots. Let's just keep dot plots in the list. And then quartiles. The last one is standard deviation and variance. But just some kind of simple questions about that. Okay. Okay, so let's just do a few definitions and then examples. Starting with the universal set. Or I guess starting with sets. Okay, we call the universal set U, capital U. It's the set of all elements possible, or all possible elements. Okay, then the empty set is 0 with a slash. Or you can put some brackets with just a comma, but nothing inside. Bracket, comma, bracket. So the set that contains no elements. Universal set, empty set, and now we talk about the union of two sets. So we'll put down union. Will be okay. A union B is the set of X in U, X in the whole space, such that X is in A or X is in B. So or means you can be in set A or set B or both. So it's kind of open as long as it's in A or B or both. Okay, next. Intersection. A intersect B is the set A and B. So the set of X in U such that X is in A and X in B. So and is kind of like condensing it down to where you have to be in both sets. All right, last one is the complement. A complement is the set not A, so all X in U such that X is not in A. Okay, we'll practice. Okay, so the universe, U, is going to have 5, 6, 7, and 8. Oh, oops. Back to what it said before, because there's a question on the side. The orange part said that it's, let me put it down a little bit. So there was the word or. And when I pointed at or, it's A or B or both. So set A, set B, both A and B, but the word and is just the intersection of A and B, so it has to be both sides. Sweet. Okay, let's draw a picture. After we make some sets. Okay, the set A contains just 6. Set B contains 6 and 8. And find okay, we find A intersect B, A union B, A complement, B complement. think it helps to draw a picture. So first we draw a picture. It's called a Venn diagram. So it's a big square. For the whole space, U, so we label this anywhere, so somewhere on the edge. Let's put it here. A is a subset and B is a subset, and we're going to overlap them just in case they share elements. So label A, the set A is this circle, set B is this circle, and that overlapping part is the set A and B. So where they have common elements, 6 is common to both sets, so we put that here. And 6 is the only element in set A. We need 2 elements in B. 8 will be right here. And outside of these sets, we have 5 and 7. Okay, A intersect B is this part right here with the overlap, and it just is the set that contains 6. Okay. A union B would be all of set A and all of set B, and we don't have to repeat, so 6 and 8 are contained in that set. A complement, so everything that's not in A. You can use your picture and cover up A. So it's things that are in set B, but outside of A, but also in your space. So 5, 8, and 7. B complement, things that are not in B. So cover up what's in set B. And then you would look in set A, but there's nothing there. And then look in the space where you have 5 and 7. All right, let's try a new one. Okay, this time the universe is still U, but it's the set that contains 10, 20, 25, 30, 35, and 40. Okay, I have a subset A, which contains 20, 25, 30, 35. B is the set that contains 25, 35, and 40. Okay, similar questions. Get A union B, A intersect B. The complement of A and the complement of B. But I like to start with a picture. So we're going to draw a picture. Just go for it. Okay. U is the whole space. We'll have set A overlap with set B just in case. They have common elements. So let's check for common elements first. The number 25 is common. And 35. Let's take care of set A. We need 20 and 30 in here. Okay, B means the number 40 over there. And then make sure you have all of the elements, which means 10 is somewhere outside here. 20, 25, 30, 35, 40. Okay. Do A union B. Okay, so A together with B, and we don't need to count these twice. We just list 20, 30, 25, 35, and 40. A and B is the set where they have common elements. Right there, 25 and 35. A complement is not A. So you cover up A and you get the elements that are not in A but are in B, and also not in A but in the space. So 40 and 10. Okay, same idea for B. You don't use any elements from B, but you can take elements from A as long as they weren't in set B. So 20 and 30. And also elements that are in the space but are not in B. 10, 20, 30. Or you can just use like the sets themselves. So if you just check that none of the elements that were in set B should be in this set here. So you should exclude 25, 35, and 40, but have all of the other elements. Should I use that part? Oh, that was not the whole space. Oops, that was the wrong thing to mark. So 20, 25, 30, 35, 40. And we were talking about B complement, so nothing from set B. Which leaves 10, 20, and 30. Just double check. Okay, so one more problem like this. Our set U contains letters, but it's still the same idea. So we're going to go with C, D, E, F, G. H, I, J, K. C, D, E, F, G, H, I, J, K. And set A contains E, F, G. B is the set that contains H, I. And we're going to find the union of A and B, A intersect B, A complement, B complement. I think we should draw a picture first, though. So let's sketch a picture. I like to start here and get all of the common elements listed. So let's see. There is nothing in common. So E, F, G in here, H, I over there. So this place is going to be empty. We'll talk about that. We'll write that down in a minute, but we'll keep on drawing. A needs E, F, G right here. B has H, I on this side. We need C, D. Got E, F, G, H, I. So somewhere we need J, K. All right, this made it worse. Let's find A intersect B. So it's in A and in B, which there's nothing in A and B. So if this were a test question, you could either write empty set or, like I told you earlier, you could put some empty brackets. But there should be a place where you can find math symbols and you can find this symbol. But if you can't find it, this is correct, this is correct. Let's move on. A union B. It's in A or it's in B or it's in both. So this set E, F, G, nothing, H, I. A complement, so the set not A. I would use the picture and cover up A. Get everything outside of A and in set B and in the space. H, I, C, D, K, J. Now, B complement is everything that's not in B, but is in the space and can be in set A. It just cannot be from set B. So I'm just going to hide set B and get E, F, G, C, D, K, J. All right, so that was our intro to sets. And now we're going to talk about frequency and relative frequency and look at some distributions. So frequency is the number of times something occurs in a set, or like the number of occurrences in an event, or sometimes we call these sets events. So number of occurrences of an event such set. Sometimes we could call, definitely next chapter, we're going to get more into some statistics ideas. And instead of saying set A, we'll say event A. We're in this set A union B is event A union B. Just same idea. And then relative frequency. Okay, equals a fraction. So in the numerator, you take the frequency for your event, and then divide that by the total number of occurrences. So everything possible. Okay, first example. So you'll see something like this. It'll say, consider the following frequency distribution. We'll have classes and then frequencies. classes are called W, X, Y, Z. I did frequencies of 5, 10, 5, 20. And we'll start with a question like this. What is the total number of frequencies? All right, so to get this total, we just add the column and get 5 plus 10 will be 15. 5 more gets us to 20. 20 and 20 is 40 total. And if that's all you put on your test, that's correct. So that's the answer. Just put 40. You don't have to show your work. Or, you know. Next question. What is the frequency for X? Okay, so we find category X or class X. It occurred 10 times. Part C. Okay, now I'm going to ask, what is the relative frequency for X? I'm just going to put like a tiny bit of scratch work to explain what's going on. So down here, we'll answer part C, and we'll have relative frequency. Is when you take the frequency for the category, which was 10, divide by the total number, which we got earlier, a total of 40. If you did write this as your answer, it would be correct, but you could also put it as a reduced fraction or as a decimal. So this would reduce down to 1/4, which you could put like 0.25. As long as it's correct. One more. So part D. What is the relative frequency for Z? Okay, so we're going to take the frequency for Z and then divide by the total. Before I erase, Z has a frequency of 20, And it was out of 40 total. Okay, could we reduce this to 1/2? We could also put 0.5. Okay, any questions or concerns? I'm going to do another example like this, but before we get there, I just want to mention that I looked back at some of my old notes, and once or twice I made a mistake of just, this is way to the side, and you don't have to write this down. So I think I had a set that looked like 10, 20, 20, 30. We were working with these sets. We don't need repeats, so this was a mistake. The set should have looked like this. So I'll try to make sure that doesn't happen again. You know, I've got a note to myself to not make that mistake again. Back to these frequency distributions. We're going to have one about colors of fish. So this one is the following, or consider the following relative frequency distribution. Frequency distribution for colors of fish in a pond. And we'll create that distribution up here. So the class, and then relative frequency. I have classes of red, blue, and gold. Here we have 5 out of 20. The next one is 7 over 20. And 8 out of 20. First question, part A. So, what percentage of fish are blue? So what you use is the relative frequency, and then we're going to change it to a percent. We have relative frequencies already, so just find blue's relative frequency, 7 out of 20. And what I would do is write this as a decimal, so grab a calculator. I have misplaced my phone, so if anyone finds the answer before I do, that would be awesome, but I'm on it. It's
0.35.
Yeah, thank you. That's great. All right, take that decimal, change it to a percentage. The shortcut is to move the decimal place twice to the right. I'm gonna put one step in the middle, is just writing this as a proportion out of 100. And any number out of 100, that's the definition for percent. So this would be a 35%. Percentages are proportions out of 100. But again, you can do a shortcut of moving this decimal place twice to the right and get from 0.35 to 35%. All right, let's do the percentage of fish that are red or gold. I'm just going to put that. Red or okay, so here we're going to add the percentage for red with the percentage for gold. Or we can do the relative frequency here added to this relative frequency and then change to percent. Either way, we'll reach the right answer. Okay, so red. And that we're going to add to the relative frequency for gold. Okay, so now I'm just going to use a calculator. Take 13 divided by 20. It is 0.65. Which we can move this twice to the right and get 65%. And I think that's good for those kinds of examples. Let's get into some interval notation, and then we'll come back next time, do a little bit more interval notation and a little bit more review. I'm going to try to get this as organized as I can. Let's do, for a symbol like this, let's say that it's read as less than or equal to, and let's pretend this is like greater than or equal to, depending on the situation. Use square brackets. To show included endpoints. And then if you, I mean, a graph won't be on the test, but a graph helps to do the problem. And if you draw a graph and you have these symbols, use a solid dot. And the solid dot means you're including the endpoint. So we'll just write, use the solid dot for graphs that include endpoints. Okay, so again, you've like less than or equal to, greater than or equal to. The interval notation, the set has square brackets when it's this symbol, and the graph has solid dots to show that you include, that you can actually equal the number. If it's a strict inequality, so no equal to sign, just strictly less than, strictly greater than. Use parentheses instead of square brackets. So those are for ends that are not included in the set. And then if you do draw a graph, we do an open circle. Use open circles for the graphs. Okay, so I'm going to try to explain with an example, and then I just have a few examples to go through. More examples next time. Okay, let's go here. So I want to talk about strict inequalities and not actually including the endpoint. the set of X and the universe is the real numbers. It's a lot to write down, so I haven't been writing that part down. It's X and the real numbers such that X is greater than 1. So you have a real number line. It goes from negative infinity to positive infinity for your X values. Your kind of critical point or number of interest is the number 1, so we need a placeholder. Maybe we'll put 2 and 0. You're looking for X values that make this statement true. X is strictly greater than 1, so we're going to get really close to 1, but not include it. So let's go ahead and put an open circle right here. Okay, I talked about test intervals. You can test numbers on this side of 1 or numbers above 1 and see, just pick one number, test it, and see if it's true or false. We can put in 0. Is 0 greater than 1? Oh, that would be false. Which makes this whole side false. You don't have to make that mark. I'm just showing you. You don't want to use this part. Something like number 2, 2 greater than 1 is true. Everything on that side of 1 is also true. And the graph is numbers greater than 1, like 100, 50, 2, but also getting really, really close to 1, like 1.00001. And even closer and closer, but never actually includes the number 1. Okay, so the answer is a parenthesis around 1 to show that we don't include that value. Into positive infinity, which on your test you can write the word infinity. And you can't include that number, it's not a number, so it also has a parenthesis. Okay, next one. Okay, the set of X So if I don't tell you what U is, just assume that it's the real numbers. So when I say X such that X is greater than or equal to 5, it's all real numbers X that make that statement true. So we do a real number line. From negative infinity to positive infinity for your X values if you want to put that part. And then we need a placeholder for 5. x can equal 5, so I'm going to start with a solid dot. We want the x values that make this statement true, and you can test everything below 5 or above 5 to check if you want to be this side or that side. Let's test 3. 3 greater than or equal to 5. That would be false. I'm going to test 6. 6 greater than or equal to 5 is true. So I want this side. And continue. Okay, so this set has numbers like 1,100, 6, 5.5, 5.0001, and also 5. So you can have a square bracket and use the number 5 in the set. Go to positive infinity, which has parentheses on it always. All right, let's do the set of x values that are less than -1. Okay, we'll draw a graph. It helps. Okay, x values. I need -1 somewhere. X values that make this statement true. And your test intervals, let's see. 1 is like what I would call a critical point, and we're going to be strictly less than that value, so a circle at the number -1. And then your test interval goes below that number, and another one is above that number. Let's test -2. So this is just extra, just splitting this in half. Let's try this one. -2 right here. -2 less than -1. That's true. I'm going to put in 1. 1 less than -1. It's false. So we're not using this side. We want to go this way towards -infinity. And up to, but not including -1. Okay, so you start from the smallest value, which is -infinity, and any, well, either positive and -infinity have parentheses. And up to -1, it's not included, so it has parentheses on it. All right. Last one for today, and then we'll come back and do more examples for this on Thursday. set of x such that x is less than 1 or x is greater than 5. Okay, this is a good practice problem, but just to let you know, I wouldn't put one of these or questions on the test, mostly because the answer is difficult to type. But still, we'll draw a graph and write down the set. Negative infinity, positive infinity for your x values. We need a placeholder for 1 and also for 5. I'm not going to include 1, so let's just have an open circle right here. We're also not including 5. It's a strict inequality for that number. Your test intervals would be below 1, between 1 and 5, and then above 5. So you can pick a number this way and test it. We'll test 0. So it just needs to make one of the statements true, or means it satisfies this side or this side. So 0 less than 1 is true. So I want to use all of that part below 1. We're going to test 3. Okay, let's try 3 less than 1. That's false. Let's try 3 greater than 5. Also false. So I don't want anything in that interval. Last thing I'll test is 6. Okay, 6 less than 1, that's false. 6 greater than 5 is true. I needed one or the other to be true. 6 greater than 5. So we'll go this way. Start with the smallest number, and then we'll union this set with that set. So parenthesis, negative infinity to 1. 1 is not included. Union 5, but don't include 5. To infinity, also not included. Okay. Okay, so that's the end for today. Thank you for being in class. I will post this meeting